So moving on to mechanism of drug absorption. So the drug absorbs through biological membrane from site of administration to systemic circulation by various mechanisms. Like there are 5 important mechanisms are there for drug absorption. Like we have passive diffusion, carrier mediated transport, under that we have active transport and facilitated diffusion, and then we have pore transport, vesicular transport, under which there are phagocytosis and pinocytosis, and then there is ion pair transport. So there are 5 mechanisms by which the drug absorbs through the biological membrane or pass through the biological membrane. Let's discuss one by one. First is passive diffusion. I already discussed yesterday about passive diffusion. So passive diffusion is nothing but movement of drug from high concentration to lower concentration. That is movement of downhill transport. Movement of drug from higher concentration to lower concentration. Passive diffusion can be explained by Fick's first law, which is the rate of absorption is proportional to the concentration gradient. So for the drug to absorb by passive diffusion, the driving force of drug absorption is its concentration gradient. That is, there must be difference in concentration. That is, one side, that is towards the site of administration, the concentration should be higher, and in the systemic circulation the concentration should be lower. So the rate of absorption will be directly proportional to concentration gradient. This can be mathematically written as, rate can be written as dC upon dt, that is change in concentration with respect to change in time, is proportional to delta C. If you need to expand this equation, then dC upon dt is equal to a constant into delta C, and if you need to expand this delta C, then this will become C1 minus C2. This is the concentration of drug in site of administration, and this is the concentration of drug in systemic circulation, where C1 is very greater than that of C2. As the concentration of drug dilute very much in blood, because the volume of blood is 6 liter. Once the drug moves from systemic site of administration to systemic circulation, immediately the drug gets diluted and the concentration of drug in blood, that is C2, will reduce to a very lesser extent that it can be neglected from this equation. So the equation will reduce further to dC upon dt is equal to K into C1, where this constant K includes some other constants like D, A, K, O by W upon H, where D is the diffusivity of the drug molecule and A is the surface area of the membrane, K, O by W is permeability, that is permeable capacity of the membrane, and H is the thickness of the membrane. The 3 parameters in the numerator are directly proportional to the rate of absorption, and the thickness is inversely proportional. You can know that diffusivity, as the diffusivity of the molecules increases, the rate of absorption increases. If permeability of the membrane increases, again the rate of absorption also increases. If area available for absorption increases, diffusion will also be more. So these three parameters are directly proportional to rate of absorption, whereas if the membrane thickness which absorbs, the thickness is more, then there will be less absorption. So the rate of absorption is inversely proportional to thickness of the membrane. So all these constants included into a single constant K. So just go through this equation. Rate is proportional to concentration, which is a first order kinetics, which means that passive diffusion follows first order kinetics. So graphically, if you need to explain this passive diffusion, so as the concentration increases, the rate of absorption increases in a linear fashion. That is, concentration and rate of absorption are directly proportional to each other. So which type of molecules undergoes absorption by passive diffusion? So generally highly lipophilic. And what about hydrophilic? All the hydrophilic molecules cannot pass through passive diffusion, but the small molecules which are hydrophilic in nature can pass through the passive diffusion. So the points to be remembered in passive diffusion are: the passive diffusion means the movement of drug from higher to lower concentration, which doesn't need any energy or ATP. That is why they are known as passive. And it is also known as downhill transport of drugs. That is, from higher towards downside it is moving. That is why it is known as downhill transport of drugs, which can be explained by Fick's first law. So the law governing this passive diffusion is Fick's first law, which is rate of absorption is directly proportional to delta C. So this can be mathematically explained as dC upon dt is proportional to delta C. So once you equate, it includes a constant, and expanding delta C will give you the two concentrations C1 minus C2. Delta is changed, so there should be difference. Mathematically, for difference we use minus sign. So C1 concentration is very greater than C2. As I already told that the drug gets diluted in the blood, so you can neglect the C and the equation will further reduce to first order kinetic equation, which means that rate of absorption is directly proportional to concentration in case of passive diffusion. Matlab kya hai? What does it mean? It means that as you increase the concentration of the drug from the site of administration, then the rate of absorption increases through the biological membrane. These are the points to be remembered, and the example for those drugs which undergoes absorption by passive diffusion are highly lipophilic drugs and small hydrophilic. As the membrane is lipophilic in nature, lipophilic drugs can easily pass through the membrane by passive diffusion, whereas hydrophilic molecules, once it is small, the pores present in the membrane will help in absorption of drug by passive diffusion. So the material for these topics which I am covering, which I am teaching, that I will be providing at the end of the topic. So next to passive diffusion is the another important mechanism, which is carrier mediated transport. So that most of the drugs absorb by passive diffusion. That is the first mechanism most of the drugs follows. And the second mechanism is carrier mediated transport. So what does it mean? Carrier mediated transport? The absorption of drug or transportation of drug with the help of carriers. So there is necessity of carriers for absorption or for transport of drugs. So under this carrier mediated transport, we have active transport and facilitated diffusion. Just check it. I have mentioned this diffusion word in two mechanisms. One in passive diffusion and another in facilitated diffusion. So always this diffusion means movement from higher to lower concentration. whereas active means which includes some ATP, involvement of ATP or energy requirements. That means when the energy will be required, when you move from plains to top of the hill, that is uphill transfer needs energy or ATP, that is movement of drug from lower concentration to higher concentration is active transport, but movement of drug from higher to lower concentration is facilitated diffusion. Now why it is facilitated? Because the absorption is facilitated with the help of carriers. So in passive diffusion there is no necessity of energy as well as carriers, but in facilitated diffusion it needs concentration gradient as well as the carriers, and the active transport moves against the concentration gradient. Concentration gradient will be from high to low, but it is moving against the concentration, that is low to high. As it moves against the concentration gradient, there will be requirement of energy or ATP requirement. That is why it is known as active transport. So which type of drugs will be actively transported? So the example for those drugs are glucose, sodium, calcium, iron. That is most of the endogenous substances which are present already in the blood will transfer by active transport, and some vitamins and minerals. Vitamins like vitamin B12. Whereas the example for drugs undergoes facilitated diffusion are riboflavin, thiamine, etc. So the common between this active transport and facilitated diffusion is that they need carrier for drug absorption. Whereas the difference is this facilitated diffusion moves from higher to lower concentration, whereas active transport moves from low to high concentration. And another difference is as it moves against the concentration gradient, ATP or energy requirement is necessary, whereas in facilitated diffusion there is no requirement of any energy. So the other common factor about this carrier mediated transport for both active and facilitated diffusion is that these both processes are saturable process. Also, they can be competitively inhibited. What I was saying, these both processes are saturable or also known as capacity limited process, and both can be competitively inhibited. Now what does it mean? So what I was saying, these both processes are saturable or saturable or capacity limited process and are competitively inhibited process. What does it mean? Saturable process. Both requires carrier. That means the carriers are limited in number so that they can be saturated, and their capacity is limited as the carriers are limited in number. There are finite number of carriers present so they can be saturated. It is not that as you increase the concentration, always the rate of absorption increases. Until the saturation of carriers, the rate will increase along the concentration. Whereas once the carrier gets saturated, even if you increase the concentration, there will not be any change in the rate of absorption. That is the meaning of saturable process or capacity limited process. Now what does it mean? Competitively inhibited. Competitively inhibited matlab, that means the carriers, say for example this is the carrier where the drug have to bind. So the carrier with the active sites, there will be some active sites where the drug can bind. So this drug to bind with this active site, they must have some binding affinity. So if any other drug having binding affinity greater than the drug which has been bound to the carrier, then that drug can displace the earlier drug from the binding site. That is known as competitively inhibited. Got it? The thing is, the drug which binds with the carrier should have some binding affinity. If any other drug which has binding affinity greater than the drug which has been bound already with that of carrier, the another drug can easily displace because it is more stronger than the earlier drug. So it can easily kick out this earlier drug, and this drug which has higher binding affinity can sit in that carrier. That is the meaning of competitive inhibition. So the carrier mediated transport has these two properties, that is they are saturable process, also they are competitively inhibited. Now moving on to the kinetics of this carrier mediated transport. This is more important. Kinetics. So we have used Fick's law for explaining the passive diffusion, whereas for carrier mediated transport, since this carrier is saturable process, you cannot use simple Fick's law. So here the equation used will be Michaelis-Menton's equation. So to explain the kinetics of carrier mediated transport, you have to use the equation Michaelis-Menton's equation, where the rate of absorption is equal to V max C upon Km plus C. As we already know, dC upon dt is the rate of drug absorption, where C is the drug concentration and V max is the theoretical maximum absorption rate, and Km is the concentration where half the maximum rate occurs. So the rate of absorption is equal to V max C upon Km plus C. This Km explains the concentration of carriers. So carrier or the binding site of carrier will be explained by this Km. So V max is the maximum rate of absorption. That is, if there will be n number of carriers, then n the rate of absorption will be explained by V max. So at low drug concentration, that means the concentration which is in denominator, this is low than that of the Km. Km is the concentration of carrier. That is, the carrier concentration is greater than that of the drug's concentration. So when at low concentration, that is concentration is lower than Km. So the equation will become dC upon dt is equal to V max C. Now Km is greater than C. So you can just neglect the C from this equation and you can write Km. That is, V max and Km both are constants. So you can combine together into a single constant, that is dC upon dt is equal to K into C. This equation is of first order kinetic equation. Now at high concentration, as there is an increase in concentration of drug, now what happens? The concentration of drug increased than that of the concentration of carriers. Now Km is less and C is greater. That is, at high concentration C is greater than that of Km. Now the equation here, it will be reduced to dC upon dt is equal to V max C upon C. Why we have written only C? Why we have neglected Km? Because now the concentration is greater than that of Km. Very greater than that of Km. That is why we have neglected this Km from this equation at high concentration. Now C will get cancelled. dC upon dt will be equal to V max, which is a constant. Rate is equal to a constant, which is zero order kinetics. So what does it mean? At low concentration, the rate is of first order kinetics, and at high concentration the rate is of zero order kinetics. That means if you graphically represent these data, that is, as you increase the concentration, the result of rate is explained as at low concentration initially, as the carriers are n in number, that is numerous in number, the concentration, with increase in concentration of drug, the rate of absorption also increases. But it doesn't happen everywhere when you increase the concentration of drug, because carriers are limited in number. So anywhere the drug concentration have to saturate those carriers. So the maximum rate will be achieved or attained at the place where the n number of carriers has been completely saturated. Once the carrier has been saturated, if you increase the concentration, the rate will not increase. Now that will remain constant. Why? Because carriers has been saturated. Even the drug will be removed from the carriers, the other increase in concentration will again saturate the carrier, and the rate of absorption will show the constant value. This is the meaning of this equation. That is, at low concentration the rate of absorption follows first order kinetics. That is, first order kinetics matlab concentration and the rate relationship will be linear, that is at low concentration. Whereas after saturation, that is when the carrier will be saturated, when you increase the concentration, that is at high concentration more than that of the Km value, then there will not be any change in rate of absorption and it will remain constant. So constant rate means that will follow zero order kinetics. Initially at low concentration first order and at high concentration zero order kinetics. So carrier mediated transport can be explained by mixed order kinetics. So you can differentiate passive diffusion and carrier mediated transport from its kinetics. That is, passive diffusion follows first order kinetics, whereas carrier mediated transport follows mixed order kinetics. That is, initially first order and then zero order kinetics, which can be explained by these equations, that is from Michaelis-Menten's equation, as well as graphically it can be explained very well. So sometimes even the short notes can come from like differentiate between passive diffusion and carrier mediated transport, or the differentiation between active and the carrier mediated transport. Then you can easily differentiate these two mechanisms. So these two are the major mechanism of drug absorption. Initially the passive diffusion, and the second one is the carrier mediated transport. So we have the third mechanism, which is of vesicular transport. So what does it mean? Vesicular transport means that is formation of vesicles. Now what is vesicles? A bag like structure, a vacuole like structure, or a sac like structure. So generally vesicles will be formed from the cell membrane. So once any drug or any foreign bodies comes near the cell, they have defense mechanism, which is also known as this phagocytosis and pinocytosis, that the cell membranes protrudes towards inside and this foreign bodies will be engulfed. That is, this will enter into this protruded area and this will be covered, and at last it makes a vesicle and it will be swallowed by the cells. So we have two vesicular transport mechanism, that is phagocytosis and pinocytosis. Simply saying, phagocytosis is cell eating and pinocytosis is cell drinking. That means where we eat solute, whereas the solution or the solvent molecules will be drank. So pinocytosis is the movement of solution or solvent, or engulfment of solution or solvent into the cell is pinocytosis, and engulfment of solute drug molecules into the cell is phagocytosis. It also includes some other mechanisms like endocytosis and exocytosis. phagocytosis. So the example for those drugs which undergo vesicular transport is Sabin polio vaccine, as vaccine contains the microorganisms. So polio, for this vaccine, for the polio virus, the vaccine has been made with the help of some microorganism virus. Again, these foreign bodies, when it enters, it have to form a vesicle and it will be engulfed. So the phagocytosis and pinocytosis mechanism will be followed in this case of example. So the another minor mechanism of drug absorption is vesicular transport mechanism. Now the fourth smaller mechanism of drug absorption is by aqueous pore transport. That is pore transport. So in last video I explained that biological membrane has some pores on the surface of the cell membrane, biological membrane. These pores are aqueous in nature or hydrophilic in nature. So generally small hydrophilic molecules can pass through this aqueous pores towards the blood. So this is known as aqueous pore transport or pore transport mechanism. So the example for those drugs which undergo pore transport are urea, glucose. These are hydrophilic in nature and they absorb by pore transport mechanism. And the last mechanism is ion pair transport, that is pairing of ions. If it is positive ion, it will be paired with negative, and negative ion, it will be paired with positive ions. That means unionized or neutral drugs absorption will be more. If the drugs are ionized, that is like strong electrolytes or ionized in nature, these drugs will have difficulty in absorption through this biological membrane. So in that case, what we can do, we can make a pairing. Ionized means either positively charged or negatively charged. So this will be of strong electrolytes and are ionized in nature, and they have difficulty in crossing the biological barriers. So what we can do, we can make this ionized into a neutral compound by pairing with the opposite ions. Example, drug amphotericin has difficulty in absorption through the biological membrane, can be given along with DSPG, which means distearoyl phosphatidyl glycerol. Amphotericin, which is ionized in nature, when it complexes with the DSPG, it becomes neutral compounds and can be easily absorbed. That's all about the mechanism of drug absorption. If you have any queries, you can mention it on the comments. And I will be providing the material in PPTs or in PDFs in my next video. So we have the summary about the mechanism of drug absorption. In my next video, I will try to explain these using PPT. For the benefit of the UG students, I am just using the board, because for UG students the concept should be cleared. The graphical representations cannot be explained by my PPTs. Only the materials will be provided, and for the sake of some students who will be needing material, I will be explaining the next video of the same topic with the help of some PPTs. So you can take either screenshot of those videos, or you can take photographs, clicks of those PPTs, and I will provide with the material, or any other chances of taking the material I will be providing. Thank you very much. We'll meet you in the next video. So I started the lecture series in biopharmaceutics subjects. So I am planning for continue for all the pharmaceutics subjects which are covered under B.Pharm as well as in M.Pharm pharmaceutics subject. So Biopharm, mechanism of drug absorption I have started. In my next video, I will be summarizing with the help of PPT, and in the further videos, factors affecting drug absorption through oral route and non-per oral route will be continued. Thank you very much.